number 8. Define molar mass. I really don't think that there is an easier definition in all of chemistry than the definition of molar mass. It is the mass of
A mole
of
a substance.
any substance.
Right.
Yeah. Simple.
Number
Number 9.
9, how to calculate the molar mass of a given compound. Well, it's the algebraic sum of the molar masses of the elements in the compound.
Right. So just add them up. We're actually going to give you a compound and you will have to add the atomic masses to get the molar mass. You can do this.
Yes.
Alrighty, number 10. How to convert moles of a given compound to mass. And we're going to give you the molar mass. We do that really just to kind of speed things up. We know as you're taking the test, it will take you a few seconds to actually add up the molar masses of all the elements in a compound. So we provide those for you so that you can focus in on actually doing the math of the question. You know what? I just said actually 3 times. And when I watch Kendall, she says actually like about 15,000 times actually. So this is a problem where you're given moles and you're turning it into grams. And you've had a couple of those already. So say we had 2.50 moles of sodium chloride. How do you turn that into grams? Well, we want to cancel moles at the bottom. 1 mole of sodium chloride is going to be what, like 58?
58 and a half-ish.
Point something grams of NaCl. You'd think I'd have that memorized.
Right.
No. In fact, so here we're just multiplying. Go back to this setup for the majority of the math problems on this test. And you're really just flipping this conversion factor to make sure that the unit that you are given originally cancels down here.
You need that to happen. If
Right.
you can't cancel, you've done it wrong.
Mr. Sussman, are your kids doing this? And I want to point this out in this example. Mine will get a problem like this, and they'll say 58.5, well, hopefully they'll say grams, sometimes that's not even there, over 2.50. I don't know why they're doing that.
Because they're guessing. Because on the 3 previous questions, they multiply.
Oh,
So in this question,
I think.
they think, oh, I've got to divide on this one because I haven't divided in a while. And no. Label and set up your conversion factor, and it shows you what to do.
Right. The other thing I'm worried about is that I'm seeing you put the given value on the bottom.
Yeah.
This goes at the beginning. Start with that.
Start with what they give
Hopefully
you.
that's just an anomaly that I'm seeing this year. Okay, number 11. How to convert mass of a given compound to moles. Molar mass will be given. That is basically just the reverse
The
of this
reverse
process.
of that. Start with what they give you. Start with what they give you.
And number 12.
Number 12, how to calculate the mass of a specific element in a given compound. This is a percent composition problem.
Actually, it doesn't look like it's a percent composition problem.
Number 12?
What do we do?
No.
Maybe we didn't update our test hint.
Maybe we didn't.
I think that's potentially the problem. Anyway, this is a simpler problem. It is, oh no, it's not. It is a percent. Oh, See,
Yeah,
it says,
it is a
it
percent.
says what's the mass of that and that.
Right. Let's knock this out. We've got, let's say we give you a sample of 5 grams of calcium carbonate. And I want to know, as the test writer, I'm interested in knowing what is the mass of calcium I ought to be able to get out of this compound. What mass of calcium can we get out of this compound? Well, if you go through here and determine a percentage of calcium in calcium carbonate, you're going to get 40%, well, 40.08% calcium, because we know we've got 40.08, right?
Yeah.
Plus roughly 12, plus roughly 48.
Roughly 100.
Right. So let's just say we get
100.087.
roughly 100. We know that 40 grams out of 100 grams of this compound is calcium, so that would be 40% calcium.
Right.
So 40% of any amount of calcium carbonate is calcium. Well, what's 40% of 5 grams? 2 grams. It would be 5.0 times 0.4. Just 2 grams.
Okay, so you're taking what percent of the whole thing is the part that we're looking for.
Right.
The element is part of this whole compound. It's actually 40% part of this whole compound. Just like the sugar was part of the gum. We did the Bite the Bubble lab.
Right.
Okay, good example.
Sure.
Number 13, what information is, in general, is needed to calculate the percent composition of a compound? Well, maybe we should have put this question first, because this is saying, well, hey, how do you solve this? Well, you had to do it in this problem right before.
You need to know the molar masses
Right.
of those elements present in that compound.
Right, we need to know the correct chemical formula, and
You mean-
atomic masses.
Oh, no, we're going to give them the formula.
No.
Uh-oh. Okay.
No, we spent a whole entire chapter learning how to write
How to
formulas.
write
They
formulas.
can write.
Gotcha.
14.
Number 14 is how to calculate percent composition of a binary compound when given the masses of each element. So if we do some CSI chem lab analysis,
Right.
and we determine that this mysterious chemical is 2.1 grams barium and 1.2 grams chlorine, how do you
How do you do that?
how do you figure out the percent composition?
Right, and where you might get tripped up a little bit, although you shouldn't, is when we've done problems in class, like on worksheets and things, we're giving you the percent and going from there. But every lab we've done, you've taken mass data. You've actually determined the mass of the substances, and instead of having to worry about the atomic masses on the periodic table. There's something they need to go to in all of these, a quantity, and that quantity is
I don't know. You got me stumped.
the mole.
Oh,
I don't take you stumped. We need to convert the masses we are given to moles and then do a ratio.
no, we don't. Not in this one.
Are you sure? In this
Yes.
one right here?
Yes.
Oh, okay.
In 14?
Yeah.
No. We're
Oh, we're doing the percent the other way.
yeah, this isn't going all the way to the empirical formula.
Gotcha.
This is a short stop.
I'm way ahead of you.
Yeah, you're getting cut short
Uh-huh.
on this particular question, which looks like it's going to be an empirical formula question,
Right.
but you know, you don't want to get caught doing more than you need to do, and
Yeah,
and
save
getting
that thought till later
bogged down in one particular question. This is just percentages. So take the mass of the substance they ask you about and divide it by the total mass of everything that's present.
Of the whole compound.
Yes.
And
Yes.
number 15 is very similar, calculating the percent of an element in a compound, but this time you don't have data from lab.
Yes.
So you do have to go to the mass numbers on the periodic table and find the mass of the element divided by the mass of the whole compound times 100. Will help you out, save you some time, and give you the molar mass in this problem.
Mhm.
All right, number 16.
16, how to set up the correct equation for finding percent composition of an element. This is very much like those OGT questions you had to do, where you had to show how to solve this problem. So we give you some information about a chemical compound, and this question is not asking you to solve it. It's show me how you would set up this mathematics.
Yeah, like showing the work. What work would
Yeah,
you
show,
show
yeah,
to
exactly.
solve this?
Show the work.
And the only thing you might get tripped up on this one is that they use the slash for the divide sign
Yes.
to fit it all on a line. So instead of putting something over something, they're doing
Something
A slash B.
B. Right.
So just read carefully. That should be pretty straightforward.
Gotcha.
17.
17.
Define empirical formula.
Another define.
Another define. Okay, this is simple. Empirical formulas are the ones that are reduced down to the simplest ratio.
Yes.
Lowest whole number ratio.
Yeah.
Pretty straightforward.
By moles, it's the
Oh, yeah.
molar ratio.
Molar
So
ratio.
this one, you do have to use that molar mass to get it down to the lowest whole number mole ratio.
Right.
Not masses, mole ratio.
So, Mr. Sustin, kind of going ahead to the next question too. One of these is an empirical formula for sure, and one of these is a molecular formula for sure. Which is which?
Well, this cannot be reduced to a smaller whole number ratio, 2 to 1. This is definitely an empirical formula. This one can be reduced, 2 to 2, can be reduced to 1 to 1, to a simpler whole number ratio. This is not an empirical formula.
Right. Now, how do you explain it to your kids? Because we talk about this being a molecule, and an example where a molecular formula is also empirical.
Right. And
And that comes up every once in a while.
yeah, that can happen. Empirical formulas can also be molecular formulas.
But not the other way around.
Well, this one is a molecular formula that's also empirical,
Okay,
right? This is a molecular formula
right.
that is not empirical.
This one can't be empirical.
Right,
This one can't.
right.
Okay. Number 19.
19? Yeah. 19. How to calculate the empirical formula of a compound when given the mass percentage of each element. In these questions, you're being asked to violate a tenet of science that we typically do not ask you to do, and that is making assumptions. You have to make a big assumption in here, which is a totally safe assumption to make. It's tried and true,
Right.
where you take those percentages, and percentage means parts per 100 parts. So you take those percentages and you assume, okay, we've got 100 grams of this substance.
Let's do a really easy one, like
You want to go back to that?
25%, no, let's do carbon, hydrogen, oxygen. Let's do like 25% hydrogen and 75% carbon.
Okay, 75% carbon. If we assume that we have 100 grams of this mystery compound, then if I have 100, what's 25 grams of 100? Or I mean 25% of 100? It's 25 grams. We're assuming that we have 100 grams of the substance. That gives us 75 grams of carbon. And now that I have masses of these elements, I can then use molar mass
Right.
to come up with a mole ratio.
So the first step is to assume you have a 100 gram sample, so you got the 25 grams, and you want to convert these to moles. So we need our train tracks.
1 mole of H is 1.00797 grams, or yeah, grams, 0.00 grams, grams cancel grams. That makes me feel happy. That's going to be 25. And then this is our carbon, 1 mole, thank you. 1 mole of carbon, 12.01 something something, 12.0 grams of carbon, and that's going to be, what is that, 5-ish?
6.25.
So, okay, 6.25 moles H, moles of C. Is this a small whole number ratio?
Well, I mean, they're kind of whole numbers,
But
but that's...
they're not very small.
Right, and this would not be good for subscripts. So remember that next and last step, which is to find the ratio of moles.
Right.
And this, we get to do this the easy way. We're going to divide both of these by whichever is the smallest, or all 3 of them by whichever one's the smallest, and
Right.
so on. So we know that 6.25 divided by 6.25 is going to give us 1, and 25 divided by 6.25 is, I have no idea, 4.
Nice,
I guess I
nice.
could have done that in my head.
Right, nice.
4,
So you have a 1 to 4 ratio.
so 4 H's and 1 carbon gives us a chemical formula of CH4.
Right.
Okay, an empirical formula. Yeah,
Yeah, let's break here.